All right, we've got this type of problem that says use your calculator to help you solve and find the value of theta in the interval given. And it can be kind of tricky. So I wanted to start off on this first one. Cosine theta equals 0.4801. It asks us between 0 and pi over 2 what the answer is. Since it asks us for between 0 and pi over 2, we need our answer to be in radians. And we would simply put in our calculator the inverse cosine of 0.4801. So for 84s and under, that's second cosine. For the Inspire, you just have to find the right button. You press enter, and you should get 1.07, and then there's a couple zeros, okay? And if you think about this answer, it asks for an answer between 0 and pi over 2. If you type in pi over 2, like if you actually try to figure out what pi over 2 is as a number, because it actually is a number, pi over 2 is the same as 1.57. And so we really did get an answer that was between 0 and 1.57. Now, it would be helpful for us to think about really quickly, instead of this interval, they could have given us a different interval. They could have asked us to find between 3 pi over 2 and 2 pi. Well, wait a second, we already used our calculator and figured out it was 1.070, so how could they ask us to find an answer between 3 pi over 2 and 2 pi whenever that's, let's see, this is 6.28, and it continues on in decimal form, and I don't even know what 3 pi over 2 is. I think it's 4 point something, 4.71. Okay, so here's the whole idea behind this. If you are given an equation, cosine theta equals this, without any sort of restriction on where your answers can be, there are two different places, remember, where cosine can equal a positive number. All smarties take calculus. So that's our acronym. So that means here and here we have triangles where the cosine of whatever the angle is would give us a positive value. So what our calculator does is it basically is telling us the reference angle. This angle right here is 1.070, which for angles in the first quadrant, that's our answer, 1.070. But if they asked us, like what we're saying here, if they asked us for this answer in the fourth quadrant, our calculator is telling us that this is the reference angle. So how far is it to get around to this line? Well, this is 2 pi, so it would be 2 pi minus 1.070. And so we would type that into our calculator, 2 pi minus 1.070, and we would get an answer like 5.213. So if they asked us for between 3 pi over 2 and 2 pi, that fits in between those two numbers, so that would be our answer. Or if they had said between 0 and 2 pi, we would put both of these as our answers because there are two places. So you have to take into account there's more than one place that whatever your angle is, whatever your trig function is, there's more than one place where it can be positive, so there's more than one answer. Our calculator, and if you've already watched the 4.7 video, our calculator only tells us one of those answers because we're actually using the inverse cosine function, which only has one answer for each thing. So you have to take what your calculator says and figure out what it's really trying to tell you. So let's try number 2, and this one I think might have been on the review. And if so, hey, then that'll help you understand what's on the review. So cotangent theta equals 0.7615. If you're on the Inspire, you don't have to, you have an inverse cotangent button, so you don't have to do this next step. But 84 and below, our first step is to flip both sides of our equation. If I flip cotangent, I get tangent because they're reciprocals of each other. If I flip 0.7615, it has a 1 on, we could put a 1 on bottom, which means it would be 1 over 0.7615. So in our calculator, we're doing second tangent, or on the Inspire, you're just doing inverse cotangent, second tangent of 0.7615. Okay, but what we already said is still true, that you only get one answer when you do this, and since they want between 0 and 2 pi, there's two different places where that happens. So let's think about where that's going to happen. Cotangent is positive where tangent is positive. So we have to say, okay, well, where is tangent positive? Tangent is positive in the first quadrant, all smarties take. Tangent is positive in the third quadrant. So these are the two places where our triangle can be. We go ahead and use our calculator in radian mode to do inverse tangent of 1 divided by 0.7615. And we get 0.91997. So I'm just going to call that 0.920. Okay, and that does sound very familiar. I think this is a problem from the review. So that's telling us what this first angle is. It's telling us the reference angle actually in both of these triangles. But here, it really is 0.92 to get here, because we're talking about an angle between 0 and pi over 2. But for this angle in the third quadrant, what we have to do is say, well, I have to start at 0, and I have to get all the way around to this line. So what is that going to take? Well, it's going to take me going pi plus 0.920. So you do second, no, not second. So you do pi plus 0.92. And you get 4.061 or something kind of like that. So that's our two answers, 0.920 and 4.061. So we have to think about where is it going to be positive, or if they gave us a negative number here, we'd say where is that trig function negative? If it's between 0 and 2 pi, we will have two answers. If it restricts it more, then we need to look at the specific quadrant that they're asking us about. If it's in the, let's do some like general rules here. Okay, if you are looking for what's in the first quadrant, you do nothing to it. Your answer is just whatever the calculator gives us, which we'll call theta. If it's in the second quadrant, well, we're going to have to do pi minus our reference angle. So you do pi minus the angle in your calculator. In the third quadrant, you're going to have to do pi plus theta. And in the fourth quadrant, we're going to have to do 2 pi minus our angle, because we're that angle short of 2 pi. So I hope that helps.